In this tutorial, we are going to see how to analyze Likert scale survey using multi-analysis of variance, which is called MANOVA. So we have this Likert scale data, and we have composite scores, etc. So you can check other videos on how to test reliability and calculate the composite score before running this test. So let's just go straight forward to the test. We are going to go to analyze. Then I'm going to go to general linear model, and then I will choose multivariate. So here I have different dependent variables. So I will have action 1, action 2. These are the dependent variables. In the fixed factors, I need to include the independent variables here. So I have education and I have gender as 2 independent variables. I could add the covariate. If I add the covariate, that's going to be called multi-analysis of covariance, or MANOVA. In this box here for the model, I will just keep it full factorial. Click continue. For the contrasts, I could just have contrasts here in education, for instance, or gender. Like if I have a simple contrast and I click last category, which means the highest education level, I could do this. Otherwise, I will also do the same for gender and simple, and I could just include, let's say, the last gender and the coding of this variable. So I will just click continue. For the plots, I will just keep this multivariate profile plots as default. I don't need any visualization for the time being. So for the post hoc test here, I could just move these variables. These are the independent variables, and I could choose, in case I have equal sample size in education, I could just include the 2K. Otherwise, I could choose Shife, or I could just include them both, which is called sensitivity analysis. So for both education and gender, so I could just see them both and see which one I would keep later. Continue. Then the estimated marginal means I could display that for the overall, or I could do it just for education, etc. So if we just do that for the overall, here I could just click continue. And then for the save, I don't need this, so it has to do with some assumption checks like Cook's distance, leverage values, and residuals along with predicted values. For the options here, I could check descriptive statistics, and I could have also the estimates of effect size to see to what extent I can accept this difference. Then observed power, so these are mostly reported. Also the Levene's test of homogeneity of variance, and then I click continue and then click OK. And this is the output, as you can see. So here between subjects factors, you have education and we have gender 3, and then we have education 4, and then here I have descriptive stats. I have education, gender, mean, standard deviation, and the n meaning the sample size. Then here for the boxes test of equality of covariance matrix, this value here is not statistically significant, so this tests the null hypothesis that the observed covariance matrices of the dependent variables are equal across groups, which is good. Multivariate tests here, you could see here that this is the intercept baseline, then we have education, then we have gender, and we have the interaction of education and gender, and you could see here the significance of, let's say, Pelle's here, and for this one it's not statistically significant, so we just have Rowe's largest root, which is statistically significant. And we could see here we are going to just have 2% of the variance happening in dependent variable is explained by education. Yeah, so you could see this like that. For gender, again, there seems to be no statistically significant let's say value, the level of the p value of less than or equal 0.05. Here for the Levene's test of equality of error variances, again, this is not statistically significant, which is good. Otherwise, there will be statistically significant violation of this homogeneity of variance. Then we have tests of between subject effects. Here you could see the different variables, their interaction. On the dependent variable, this is the R squared, which is less. This means that this model does not have really a high predictive power, let's say, against our, let's say, theoretical framework or model. And these are the statistically significant differences, the partial eta squared and the other statistics. So this is needed in hypothesis testing. Then we have custom hypothesis test index. You could see this here, especially on SPSS, the latest versions. Then we have these contrast results key matrix, as you can see again. So there are a lot of tables, but we don't need all of them. So we are just going to pick the most important ones with regard to hypotheses. For example, here this was significant for the univariate test, and this is for the custom hypothesis test number 2, multivariate result test, univariate test results, estimated marginal means for action 1, action 2, and then action 2 has the highest mean in terms of this. Then we have the post hoc test, we have Schiffe and 2K HSD. So depending on the sample size, we could see what to adopt. So since we don't have equal sample size, we could go for Schiffe test. And then this is in brief how we go about the analysis. As you see, MANOVA is a bit complex to run and interpret. And if you have questions or remarks, do not hesitate to post it below. See you soon. Bye for now.